Every second of every day, something incredible is happening beneath your feet. The Earth is spinning. Right now, whether you're sitting, walking, or scrolling through your phone, our planet is rotating at about 1,670 kilometers per hour at the equator. That's faster than a jet plane. Yet we don't feel a thing. But have you ever stopped to wonder why? Why does the Earth keep spinning? And why hasn't it stopped after billions of years? Let's rewind all the way back about 4.6 billion years ago, when the solar system was just a chaotic cloud of gas, dust, and cosmic drama. Everything back then was crashing, clumping, and colliding. Tiny particles started sticking together due to gravity, forming bigger and bigger blobs. And one of those blobs eventually became our home, the Earth. Now, here's the key part. In space, motion never starts for free. Something has to give it a push. So, where did the spin come from? It came from those early collisions. When chunks of rock and dust smashed together, they didn't hit perfectly straight. Some came at an angle. Those angled hits gave the growing planet a little twist. Imagine rolling a snowball and accidentally flicking your wrist. That's how the Earth started spinning. And here's the mind-blowing part. Once something in space starts spinning, it doesn't stop easily. That's because of one of physics' coolest rules, the law of conservation of angular momentum. It basically says, if no outside force messes with you, you keep spinning forever. Kind of like a fidget spinner keeps twirling until something like air resistance or friction slows it down. But wait, you might ask, doesn't Earth have friction? Doesn't it have an atmosphere? Shouldn't it slow it down? Good question. Yes, Earth does experience tiny friction forces from air, from tides, and even from the moon. But compared to the scale of our planet, those forces are incredibly small. It's like trying to stop a bowling ball by blowing on it. You can try, but it's not going to do much. See, in space, there's almost no friction, no air, no drag. So, once Earth got that initial spin billions of years ago, there was nothing to stop it from rotating. The only things that slightly slow it down are gravitational interactions, mostly from our moon. The moon's gravity pulls on Earth's oceans, creating tides. Those tides push back a little on Earth's rotation. This tug of war between the Earth and the moon is why our days are getting longer, very, very slowly. Scientists estimate that 600 million years ago, a day on Earth was only about 21 hours long. So, yes, technically the Earth is slowing down, but at a rate so small that you'd never notice unless you had a time machine. Here's something cool. You can see this conservation of motion everywhere. When an ice skater spins and pulls their arms in, they spin faster. When they stretch out their arms, they slow down. That's angular momentum. The Earth is basically doing the same thing, except instead of a figure, skater, it's a massive rock covered in life, clouds, and existential dread. You might also wonder, if the Earth is spinning that fast, why don't we feel it? It's the same reason you don't feel motion inside an airplane, because you're moving with it. The air, the trees, the oceans, and even you all move together with the planet. There's no sudden jolt, no change in speed, so your body doesn't notice that you're basically on a 12,700 kilometers wide spinning ride through space. Let's talk numbers for a second. At the equator, the Earth's surface moves at about 1,670 kilometers per hour. Closer to the poles, it's slower. That's why rockets launch near the equator, because the planet's spin gives them a speed boost when blasting into space. It's like catching a moving escalator. Except that escalator is a 6.4 trillion-ton ball of rock and lava. Now, is there any chance the Earth could stop spinning one day? Technically, yes, but not anytime soon. If the moon keeps tugging on us, the rotation will keep slowing down, and billions of years from now, Earth could become tidally locked with the moon, meaning one side always faces it, just like how the same side of the moon always faces us. But don't worry, by then the sun will have expanded into a red giant and swallowed the Earth anyway. So, yeah, you'll probably have other problems. Another fun thing to think about: what if the Earth suddenly did stop spinning? The results would be dramatic. Everything on the surface, oceans, air, cars, people, would keep moving at the same speed the planet was spinning. That's over 1,000 miles per hour. It would be the most terrifying brake check in the history of the universe. Thankfully, physics doesn't allow that to happen overnight. And here's something truly poetic about this whole thing. The reason the Earth spins and keeps spinning is the same reason you exist. That original spin helped shape the planet's climate, created day and night, and influenced the rhythm of life itself. Without that motion, there would be no sunrise or sunset, no weather cycles, and maybe no life at all. But let's not forget, the Earth's spin also gives us gravity's dancing partner, centrifugal force. It's the reason you weigh slightly less at the equator than at the poles. It's also why the Earth isn't a perfect sphere. It's a bit squished, like a slightly overinflated beach ball. So even in shape, our planet shows the fingerprint of its eternal motion. Here's something even wilder. When astronauts look down at Earth from space, they see it rotating slowly, peacefully, like a giant blue marble turning in sunlight that spin we can't feel here on the ground. From up there, it's mesmerizing. It's one of those things that reminds you how small we are and how big the forces keeping us alive truly are. If you could somehow watch Earth in slow motion over millions of years, you'd see it gradually slow down, but never completely stop. Because in the vacuum of space, motion doesn't just disappear, it lingers. It persists. It keeps going, quietly, endlessly. Just like the heartbeat of our planet. So the next time you look at a sunrise, remember this: you're not watching the sun move. You're watching the Earth spin a motion that began before humans, before dinosaurs, before life itself. Every day, this rotation gives us morning and night, balance and change, and maybe, just maybe, a reason to keep spinning ourselves. The Earth doesn't stop because the universe doesn't waste motion. Once it starts, it keeps going. And maybe there's a metaphor in that too. No matter what happens, just keep spinning. Don't forget to like, share, and subscribe to OrbitIQ, where science becomes something you can actually feel, even when it's moving at 1,000 miles per hour.